This is number 39 in your homework. That threw me for a bit of a loop in our class lecture. But I want to show you how to do it. This is the hardest one you will see, and it gets pretty complicated, but it's really simplistic. This was our original problem. We wanted to convert this into two partial fractions. We wanted to look like this plus this. Now, ignore for a minute what I've got in the pink. Because my degree of this, these are my two factors that I have in my denominator here. Because this has a degree of 2, I've got a 2 in my exponent here, I need a degree of 1, basically 1 less than the degree of the numerator, for my equation up in the numerator. Same with this guy over here. Degree of 2, now I want a degree of 1 for my numerator. I am going to assume A and B and C and D are all different numbers. And so I'm going to basically solve for A, B, C, and D. I do that first by getting my denominators equal on both of these terms here, which is what you would do anyway if you had a rational expression. If you had these two by themselves, you would say, okay, what's missing in this denominator? Well, it's the x squared plus 1. What's missing in this denominator? It's the x squared plus x plus 2. Multiply top and bottom by those, and you will then have your numerators all correct. And you can set them equal to each other, which I've done here. I've also put in the 0 x squared. I don't have an x squared term in here, but I want to get that space filled up. So I have this here is equal to, and when I expand all of this out, I get ax cubed plus bx squared plus ax plus b. I'm basically foiling these, this term, ax plus b, times x squared plus 1. And then all of these terms are basically foiling cx plus d to x squared plus x plus 2. I'm going to have 6 terms with that one. And here they all are laid out. And then I have grouped them by how they apply to the power of x. I have a plus c here, b plus c plus d here for x squared, a plus 2c plus d for x, and b plus 2d for the 5. And then I set up my system of equations here. A plus c is equal to 2. B plus C plus D is equal to 0. A plus 2C plus D here is equal to 7. And B plus 2D over here is equal to 5. I have a lot of gaps in here. I'm going to rewrite this now as a system of 4 unknowns and 4 equations. And I have put the numbers in front. 1a, 0b, 1c, 0d equals 2. I've done that for all of them. Now I'm going to erase and solve. This is equation number 1, this is 2, this is 3, and this is 4. To go after my triangulation, I already have zeros in 2 of these slots here. I'd like to make a 0 there. What I'm going to do to get that is subtract equation 3 from equation 1. That's going to give me a 0 there. So I'm going to say 1 minus 3 is, and I'm going to go 1a plus 0b plus 1c plus 0d equals 2. Then I'm going to subtract minus 1a plus 0b minus 2c minus 1d is going to give me negative 7. I'm going to add those all up, and I get 0a, 0b, minus c, minus d is equal to minus 5. And so now I can write that in there. Zero A plus 0b minus 1c minus 1d is equal to minus 5. So now I want to get rid of, I want to combine these, but as I do this I realize hang on. If I combine these two, 2 and 4, I'm going to have 0a plus 1b plus 1c plus 1d equals 0, and 0a plus 1b, I'm looking at 4 now, plus 0c plus 2d equals 5. If I subtract this one, I'm going to get 0a plus 0b, which is what I want, plus 1c plus 3d equals, oops, nope, 1c minus 0c, 1c. 1d minus 2d is minus 1d equals minus 5. So I can now write that in here, 0a plus 0b plus 1c minus 1d equals minus 5. I see right now that I have an interesting, I actually am done now. I've got my, almost got my triangle, I just need to wipe this out. But I'm going to find, look at these two equations when I combine them together. I have minus 1c minus 1d equals minus 5. Then I have positive 1c minus 1d equals minus 5. I get an obvious thing here. If you look at it, c has to be 0. It can't be anything else because everything else is identical with these equations. So if I know now that c is 0, let's just write this down. C equals 0. Got one of the 4. Now if c is 0, that means that minus, let's go to this, minus 1d equals minus 5. That means that d has to be 5. Minus 1d, d has to be 5. So they're falling very quickly. If I know that c is 0 and d is 5, then I go to this one right here, b, c, and d, and I'm going to now substitute that. 1b plus 1c, which is 0, plus 1d, which is 5, is equal to 0. That means b has to be minus 5. And finally, up here at the top, if I know that a and C equals 2, and C is 0, then A has to equal 2. So now I can rewrite this. I have 2x cubed plus 0x squared plus 7x plus 5 equals over x squared plus x plus 2 times x squared plus 1. That now equals my ax plus b is going to be 2x plus a negative 5 or minus 5 over x squared plus x plus 1 plus c is 0. I can erase all this now. C is 0, so I have a 0x plus 5d over x squared plus 1. My final answer then is just going to be 2x minus 5 over x squared plus x plus 1 plus 5 over x squared plus 1. And I've done it. I've broken this into two partial fractions.